Hi, this is Nelson again with video number 3 in the coronavirus lockdown homeschool series. So we're continuing with the idea of density and with some practical things that you can do at home. So first of all, we need to get an idea of what density means. Now, there's two figures involved in density that you will recall perhaps I was working with in the last video. There's the weight of the object and the volume of the object. Now water is kind of special. Water is specified, or the way the units have been worked out. 1 cubic centimetre of water weighs 1 gram. So, and it's also 1 mil of water weighs 1 gram. Now the convenient thing is that 1,000 grams is a kilogram and 1,000 mils is a litre. And so 1 litre of water weighs a kilogram. So this jug here, this is a 1 litre jug. If I fill this up with cold water, that will be a kilogram of water in there. So it's the weight for a certain amount of volume that it takes up. Now, for some people that takes a little bit of grasping because you've got two numbers that relate to one another and there's some really simple arithmetic or mathematics that you do on them. So what we say is, we say the weight per volume. Weight per volume. And for the examples we're doing, it's grams per cc. Grams per cc. Now, another way you can write that is grams slash cc, like so. Which is, there's a lot of things like that, like kilometres per hour. You write km slash hour. So that's the number of kilometres that you travel in each hour. And if you're doing that on a calculator to work out what that proportion is, it's actually a division sum. So you have grams divided by cc's equals the density. So you can pause for a while if you like and have a think about that if I'm going too fast. But I have to go on. So as another example, let's look at the density, how it's squashed in, if you like, this blue styrofoam or polystyrene is. So we'd say this is light substance. It has a low density. Let's just quickly figure out what that is. So we need to get the volume of this. It's 1 centimetre thick. It's 10 centimetres wide. And it's 19.7 centimetres long. So if we quickly do that calculation, 1 times 10 times, what did I say, 19.2 I think, times 19.2, do that on the calculator. 1 times 10 is easy, it's 10 of course. 10 times 19.2, I can do that in my head, that's 192. That's 192 cubic centimetres, 192 cc's. So what's the weight of it? Got some little scales here, suitable for weighing small objects. We switch them on, and once it comes to 0, we gently put that on, and it's 13 grams, actually 13.06. 13.06 grams. So to get the density, remember it's weight per volume. So we go 13, we'll round it to 13, divided by 192 equals. So calculator is here, not to confuse it with my cell phone. 13 divided by 192 equals quite a small number, 0.067. 0.067. So that's the calculation. It's got a very small number for its density. It's a very light substance, a very low density substance, so it'll definitely float on water. I won't not even do that. We obviously know that that's going to float on water. But that's an example of the sort of number you get. Okay, so that was easy because it was a simple block shape. You can measure that with a ruler. So I suggest at home you find some blocks of wood or something like that, measure the 3 different measurements on it, multiply them together, make sure it's all in centimetres, and that will be your volume in cubic centimetres. Weigh it on some kitchen scales in grams and do that calculation. The weight in grams divided by the volume in cubic centimetres equals the density. Okay, so you do that for a block of wood. There's another way to do this. Some things, I'm curious as to what the density of glass is. Here's a glass food dish. Now I can't really, it's only got thin walls. There's no point measuring all across that and pretending it's a box. It's not full of glass. The way I can do that, I can measure its volume by displacement, how much water it displaces when I dunk it down inside a container of water. Now you might have heard of a dude called Archimedes, and he is said to have hopped into a bath full of water and it spilled out due to his volume displacing the water, and that allowed him to have some new ideas, and he ran down the street naked, having jumped out of the bath, yelling "Eureka, Eureka," which was Greek, I think, for "I have found it, I have found it." Now it's not sure historically whether that actually happened, but the name has stuck, and in labs you'll sometimes find a thing called a Eureka can, which is designed to spill out water in an exact way so you can measure the volume, and you can make one yourself. So here's a plastic container, a Rooster's beer flagon with a hole poked in the side with a scissors, a drinking straw put in there, if that shows clearly, and done it with hot glue. So what we do is we fill that with water until it spills out through that hole. So that one needs to be held down there. I've made some water blue so that it looks good. And the other thing I do when we're doing this kind of work is if you add a little bit of dish detergent, or ideally or the stuff you put in dishwashers, rinse aid, it makes the water flow a little bit better out through small holes. So we just fill that up. It'll froth a little bit, but let's not worry too much about that. And we keep on filling it up until it spills. We catch the spillage because I don't want to make a mess. Hopefully that froth will die down. So we fill it right up until it comes coming out that hole. We'll wait till that settles, till we've got no more coming out of the hole. I'll actually put my teacup under there because that will fit, catch the dribbles. Just trying to get rid of a bit of that froth on top. So wait till that stops dribbling, and then to find the volume of this glass object, we can put it in there and see how much water comes out the hole. But first of all, let's weigh that object, because after we've put it in there it's going to be wet and that will affect its weight. Oops, you mustn't wobble it too much. So let's measure the weight of that glass thing first. 282 grams. So better write that down. 282 grams, so this is glass. 282 grams is the weight. So then the next question is, what is the volume? So what we do, let's stop dribbling. We put a little catching jug under there that's got volume measurements on it. It's not terribly accurate, but it's the best we can do with what I've got in this household, and you may not have anything better in your household. So we very gently put that in, But you can do this with a jug that just happens to have a long spout. The trouble with that is it tends to just run down the side of the jug. And if you put this in too fast, what I'll do is I'll zoom in on that, because now that I'm set up with this remote system. There we go. We're displacing the water coming out the hole. We let the thing go to the bottom, make sure there's no air inside it, and wait till the water stops coming out the hole, and see how much water we've got. Now while that's settling, I want to tell you what we did once. When I was teaching this at the high school, the question was, what is the density of a student? So I made a thing like this. It had to be bigger than this because you can't fit a student in there, obviously, at least none of the students that were big enough to go to high school. So we, instead of having this particular container, we got a rubbish wheelie bin. You know, they're sort of 200 litres, regular bin. Bored a hole on the side, glued a hose into it for the water to come out near the top, and then filled the thing with water until it came out the hole, and once it had stopped dribbling, the student got in the wheelie bin and got down and down and down inside the bin, and eventually held their breath and put their head under the water until they were completely submerged, and we caught all the water that came out the hose and measured its volume. Then later, the student hopped on the kitchen scales, got their weight, and worked out their density. And their density was about 0.95, or a bit less than water, which makes sense because the student floated a little bit. They had to hold themselves down in the bin because, as I said the other day, in the previous video, their lungs are full of water, full of air, sorry, as they need to be when they're in a diving position or going underwater. Okay, so that stopped dribbling enough. Just put the cup there to catch any more stray dribbles and see what volume we've got there